Today we will be looking at page 943, 1 through 23 odd, 25 through 26. This is solve and graph inequalities. And we're talking about of the one variable variety. Okay. I'm going to do some problems that are not these problems, but ones like these problems so that you could go back and do the ones that you're asked to do. I'm going to look at problem number 3. So this is like number 3. Not exactly number 3, but so similar to number 3 that if you can understand this, you will certainly be able to understand number 3. Okay. So, like number 3, 7 greater than or equal to x minus 3. Alright, our goal is to solve for x. That is, get the x by itself. So, we must undo this subtract 3. Well, the inverse of subtraction is addition, so I will add 3 to both sides. The 3 cancels with the 3 to leave x on the right-hand side of the inequality. I preserve my inequality. 7 plus 3 is 10. So I have the statement 10 is greater than or equal to x. We could graph this, but we're going to rewrite this statement such that the x is on the left-hand side. X. Notice the less than is pointing towards the x, so we will again point it in this direction. 10. To say that 10 is greater than or equal to x is equivalent to saying x is less than or equal to 10. Now I'm going to graph this statement. X is greater than or equal to 10. I will come with a number line, and I don't have to show every single point on the number line. I'm going to show 3. I'm going to show 0. I'm going to show the value of interest, which in this case is 10. And I'm going to show one number to the left of 0 so that I'm able to establish that I know where my positives and negatives are. So, I want to graph the solution set x is less than or equal to 10. I come to 10 and I draw myself a point, a circle. Since we have equal to, I'll need to color in that circle. 10 is a possibility, and I want values less than 10, so we will shade to the left. The inequality, provided the variables on the left side, will show you the direction to shade towards. The arrow on the end indicates that we're going infinitely in that direction. This number line is showing that values less than 10 satisfy our inequality. Let me show for an example. Well, a number in here might be 7, substituting 7 for x. 7 minus 3 is 4. Is 7 greater than or equal to 4? Well, yes, it is. 7 is a solution to this inequality. Consider a value outside of the shaded region. A value over here might be 15. 15 minus 3 is 12. Is 12 greater than or equal to? Is 7 greater than or equal to 12? No, it is not. That's a false statement. Therefore, 15 is not a solution, nor is it shaded. So, x greater than or equal to 10 is our statement. This number line with the shading is another way to express this statement. All right, let's look at one. Like number 13. This is not 13, this is like 13. Once you see this, you should be able to perform number 13. 4m less than or equal to 20. The goal is to solve for m. That is, we want to get m by itself. Currently it's 4 times m. The inverse of multiply is divide, so I will divide by 4 on both sides. 4 divides 4 to leave m on the left. We preserve our inequality. 20 divided 4 is 5. So, m less than or equal to 5 is my solution set. I will now graph it. 0 in the middle. 5 is my value of interest. And I'm going to pick one number on this other side, maybe -7. I want values, m, such that we are less than or equal to 5. Again, circle on 5, colored in point, because we can be equal to. Since it is equal to, we have the colored in point. This colored in point we call closed. We want values less than, so again we will shade to the left, because as we move left on the number line we have less than values. We indicate with an arrow that it extends infinitely. All values of m such that m is less than or equal to 5, and that's what my number line shows there. Alright, let's consider one from the bottom. 25. This problem will be like number, let's choose 26. Okay. 26, like number 26. 4z minus 3. I'm going to change this one to a greater than. (21). Okay. Our goal is to solve for z. That is, we want to get z by itself. So we will first deal with the subtract 3. The inverse of subtract is add. Whatever we do to one side, we do to the other. 3 cancels with 3 to leave 4z in the left expression. Preserve our inequality. 21 plus 3 is a 24. Alright. We want to get the z by itself. Currently it's 4 times z. We will divide by this 4. We call the number connected to the variable the coefficient. The letter, the variable. Dividing by 4, the coefficient. 4 divides 4 to leave 1z. We simply write z. 24 divided by 4, that's 6. We preserve the inequality. We have z greater than 6. Let's graph that. Here's 0. Here's some negative number, and then we want positive 6, perhaps here. Notice this time, since we have greater than, the inequality appears to be pointing to the right. We're going to be shading to the right. Z is greater than or 6. It can't be equal to 6, therefore this time we will have an empty point. This empty point is called open. We get the open when we don't have the equal to. We get the closed colored in circle when we do have the equal to in our inequality. Alright, we want values of z such that z is greater than 6. So in this case, we're going to shade to the right. Here we see six is not in our solution set. We need values greater than 6. 0 is not in our solution set. In fact, we can substitute 0 in C. 4 times 0 is 0. 0 minus 3 is negative 3. Is negative 3 greater than 21? False. 0 is not in our solution. But let's try numbers over here, like 10. 4 times 10 is 40, minus 3 would be 37. Is 37 greater than 21? True. So 10 is in our solution, and we would see that we would indeed, 10 is in our shaded region. Okay. One final problem. This will be like number 17. Negative 5m greater than or equal to negative 30. Okay, again, our goal is to solve for m, that is get m by itself. We will divide by the coefficient, negative 5. Whatever we do to one side, we do to the other. Negative 5 divides negative 5 to leave m. The greater than will become less than. Negative 30 divided negative 5 is 6. So, why did the greater than become a less than? Well, only when we are dividing and multiplying by a negative number do we change the direction of the inequality. That's a very important note. Let's write this down on our paper. When we divide or multiply by a negative number, we change the direction of our inequality. When we divide or multiply by a negative number, we change the direction of our inequality. The inequality is the greater than or less than symbol. Here it's greater than or equal to. Since we divided by a negative, we change the direction to make it a less than or equal to. Now we're prepared to graph m less than or equal to 6. Number line, 0, value of interest, one number on the other side. Okay. I want less than or equal to 6. Well, I need my closed point. Why closed? Because we have the equal to. 6 is a possibility. It should be shaded. We want less than. Again, the inequality appears to be pointing in the left direction. It makes sense. Values less than are to the left. There we have it. M less than or equal to negative 6, starting at 6, colored in point, shading in the less than direction. With these examples, you should be able to complete the rest of our assignment, which is page 943, 1 through 23 odd, 25, and 26.